What if you could actually predict the future? Seriously, not with some crystal ball, but with data. Well, today, we're going to pull back the curtain on one of the most powerful tools for doing just that, linear regression. Now, I know it sounds super technical, but trust me, by the end of this, you'll see how it turns plain old data into game-changing decisions.
Okay, so picture this. You're running a business. You've got this mountain of data on everything that's ever happened. But the million-dollar question is, how do you use all that past info to figure out what's coming next? How do you make smarter bets on the future instead of just guessing?
So to make this real, we're going to follow the story of an online electronics retailer. They're trying to figure out a really simple but totally crucial question. What actually gets people to buy their stuff? Their journey is going to be our roadmap.
All right, so where do you even begin? Well, the very first step is to just look for simple relationships in the data. For our retailer, the big question is pretty straightforward. If we pour more money into advertising, do we actually sell more products? Let's dive in and find out. To figure out if two things are connected, we use a cool little tool called correlation. Just think of it like a relationship score that goes from -1 to +1. If the score is close to +1, it means they move up and down together. You know, like ad spending and sales hopefully do. If it's close to -1, they move in opposite directions.
Okay, but listen up, because this is maybe the single most important rule in all of data analysis. Correlation is not causation. I'll say it again. Just because two things move together, it doesn't automatically mean one caused the other. It's a clue, a hint that something's going on, but it's not proof. And that's a huge distinction.
So we've spotted a connection. We know advertising and sales seem to be linked. That's great. But how can we actually use that link to predict what sales are going to look like next month? This is where we go from just seeing a pattern to actually building a predictive tool.
And that brings us to the hero of our story, simple linear regression. It's really just a fancy name for a method that draws the single best straight line through our data points. It connects our input, the thing we can control, like how much we spend on ads, to our output, the thing we really want to predict, like sales.
So this line, it's really just a simple recipe with two key ingredients. The intercept is our starting point, like how much would we sell if we spent $0 on ads? And then there's the slope. That's the exciting part. It tells us our return on investment. For every extra dollar we spend on ads, how many more dollars in sales can we expect to see? And this is where it gets really powerful. For our electronics retailer, the model spits out this exact equation. This tells them two critical things. First, their baseline sales are around 4,600 units. But more importantly, for every 1 unit of advertising they spend, they can expect to get 7.7 units back in sales. Now that is an insight you can take straight to the bank. But wait a second. You could draw a million different lines through all that data, right? I mean, how does the computer decide that this specific line is the absolute best fit? What makes it the right one? The magic trick behind this is a process called the method of least squares. Imagine for a second you're trying to draw one line through a whole cloud of data points. For every single point, there's going to be a little gap between it and your line, right? We call that an error. Well, the algorithm's job is to find the one and only line that makes the grand total of all those little gaps as small as it can possibly be. It's the line that's, on average, closest to all the data at the same time. But of course, the real world is messy. Sales aren't just about advertising. What about the price of the product, or whether you're running a discount? Our simple model is a good start, but to get a really clear picture, we've got to add more ingredients to the recipe.
And this slide just perfectly shows how we level up. We move from simple regression, which is just one cause leading to one effect, over to multiple regression. And here, we can throw a whole bunch of factors into the mix, things like advertising, price, and discounts to get a way more complete and powerful prediction of that one thing we care about, sales. Now, what's so awesome about this is that the model can actually untangle all these different effects. It can tell us exactly how much a change in price impacts sales, all while holding the ad budget constant. This lets us see which levers really have the biggest bang for their buck.
Okay, so far so good. Our model is chugging along using numbers like price and ad spend. But what happens when we have data that isn't a number? You know, something that could be super important, like which region a sale came from. How do we get our math-based model to understand geography? Yeah, here's the catch. You can't just tell a math formula to multiply by the word east. It just doesn't work. It speaks in numbers and only numbers. So we have to get a little clever.
We need to find a way to translate these text categories into a language the model can actually understand.
And that clever solution is a neat trick called one-hot encoding. Basically, instead of having one region column with text in it, we create a brand new column for each region. Then, for every sale, we just put a 1 in the column that matches that sales region and a 0 in all the others. It's kind of like turning the region into a series of simple on-off switches, which the model totally gets.
Okay, we've done it. We've built this pretty sophisticated model. It's got numbers, it's got multiple factors, it even has our categorical data in there. We did all the hard work. But now comes the single most important question you can ask. Is this thing actually any good? To grade our model, we use a score called R-squared. Think of it like a report card for our model. It's a number between 0 and 1, and it tells us how well our model's predictions actually line up with reality. A score of 0 means the model is basically useless. A score of 1 means it's a perfect crystal ball. So the higher the score, the better our model is at explaining what's driving sales. So after putting in all the work, adding advertising, price, discounts, and region, our retailer's final model gets an R-squared of 0.72. Okay, but what on earth does that number actually mean in the real world? It's actually pretty straightforward. It means our model can explain 72% of why sales go up or down. That other 28%, well, that's caused by stuff we haven't included in our model yet, like what competitors are doing or maybe the time of year. But honestly, for any business, being able to explain nearly 3/4 of your sales, that's incredibly powerful.
And this table basically tells the story of how we built this thing piece by piece. We started with just advertising, and that explained about 55% of sales. Then we added price and discounts, and that bumped us up to 68%. And finally, when we threw in the sales region, we got all the way to 72%. And just look at that prediction error column. That's how far off our guesses are on average. We cut that error almost in half. Every new piece of relevant data made our model smarter and more accurate.
So, let's wrap this up. What's the big takeaway here? Linear regression isn't just some boring math equation. It's a powerful framework for forecasting the future and, even more importantly, for understanding which levers you can actually pull to change that future. It takes a messy, confusing spreadsheet of raw data and turns it into clear, actionable intelligence.
We followed our retailer's journey, and they figured out what really moves the needle for them. And that just leaves one last question for you. Whether it's in your business, your career, or even just a personal project, what are the key drivers you need to understand? What important relationships are just sitting there in your data waiting to be discovered?